Alright, so let's do this. And wait for that to render. There's a bug in this image. This here. Let's change this. Add some zeros. Recompile and run it. See what it's like. There you go, that's better. Yeah, so this is kind of good. And then the one that I just deleted is going to be bad. Let's let that render. Right, then we can compare the two. This is bad. I selected just to move to the top corner here and then just flip between them. Okay, so this is what we're gonna try and kind of work on. See this little kind of light spot under. This is kind of also weird. This is the way we deal with self-intersection. So if we intersect a surface and then bounce a ray off that, and then the ray origin is like right up against the surface, it might intersect that same surface again. So we deal with that by kind of offsetting the origin of the ray off the surface. But C-ray is not dealing with it very well. So the way we currently do that is we the scene global offset with this little magic incantation here. Basically, a heuristic that you take the diagonal of a bounding box. Oh yeah, illustrate to you a box. This is not it's a floppy box. The diagonal, so from like this corner to this corner here, and then multiply it by some coefficient. And this bounding box, the root bounding box, is basically the minimum axis aligned bounding box and contains everything in the scene. And then we multiply constant here. This is not correct. Told it should be 0.1% of the distance. This is like, what is it? So 1% will be 0.001. So that's like 0.001 or whatever. The proper way to do this is instead of having a global scene offset, you would have object offset. So each of the objects in the scene, the sphere, all the stuff, they all have their own offset. Then that we use in the actual path tracing. So we're gonna try and see if we could do that real quick here. The sun is warming up, so I'm gonna try and get this done fairly quick. We'll see if we can get working. So first deal, we're gonna get global offset, because that's just not a good way to do this. Get rid of this. Yeah, get rid of that. And then we want to, I think we want to do it in compute top level BVH. Let's see. Maybe the thing is, I think it's gonna be like per instant. Or should it be per object? Let's see. SB box and center. Right. So this is where we do the top level BVH. So each object has their own volume hierarchy, and then this is gonna be the top level hierarchy that basically selects the correct object, and then we start traversing that object. So let me just get acquainted with the here. Okay, we'll make empty box. Just thinking, where should we actually do this? We actually want to see, load up the scene. So if we actually go to the scene, the world, we have, and this is not highlighting the code properly, but that doesn't matter here. we have a top level BBH, and then we have an array of instances, and then we also have an array of this. I'm thinking, should we store in the mesh or in the instance? Let me think. I think we want to do it in the mesh, because then we're just duplicating data, because a single object can have a bajillion instances. There's no reason to duplicate that. Let me get rid of the charging my headphones. So we're going to store it in, and then I'm going to see what data type we used, because I already deleted the code. Yeah, just look at float there. I'm going to call it ray offset. And then I think while we're doing the top level BBH, we might as well stick that logic in there. I think. So get instance bbox and send. Yes, and then right. Wait, what? Oh, right. Yeah, we give it the instance. Right. So in the instancing code, we basically an instance is currently had two types of mesh or a sphere. It has the composite transform that we use to move to the object local space or the local space and back to world space, and it's got action function point, then the actual bbox and center function. Now, when we make a new, let's see, when we make a new mesh instance, yeah, we give it mesh. Okay, root bounding box. Let's see, what over here? Intersection function. Let me just kind of intersect mesh, right? And here, yeah, I think while we're intersecting the mesh, we have the instance and the array we're gonna offset here instead of let's see where it happens correctly. So right now in top level C, where we find the closest intersections, this basically ties all the bounding volume hierarchies and the instancing together to get the closest intersection. We offset it here. We don't do this here. So you're gonna yoink that out of there, and we're gonna send the instancing code where it kind of belongs. So make a copy of the array. Let me see here. Where do we get? Yeah, we get the object here. We want to offset it there. So we'll worry about the building part in just a bit. So the let me see here. Do this. Offset, and then we're going to do it like this, I think. And then this is going to be the rate. Oh. Oops. There you go. It is qualified. Oh yeah, we got the copy that we make so we can mess around with it. Okay. Wait, what? Start? Yeah, that is it. Oh, right, because that's a value. Cool. So something like that. And then we're gonna do the same sphere. I'm just gonna copy this code, in fact. Or else we're gonna have to modify this. So yeah, I guess, yeah. Right, and then interact sphere. Let's see. Right. Yes, that works. Okay. And then we want to actually compute the offset. So that happens building a building the I guess the top level BVH would be the logical place. So get mesh B box in center. This distance and a bounding box and returns a center. Returns a B box in center. Okay. Let me see. Top level BVH, yes, baby. There we go. B box is I and center I. Count. Right. What happens with bottom level BVH? Let me load scene. We have a narration structure. This is the multi-threaded one. Yeah, build bottom level BVH. Yeah, it would have to happen in the DOP because we don't even build a bottom level BVH for all the objects. Top level BVH. Yeah, so we pass the instances and the instance count. Right. Top level BVH. Yes, okay. Do we do it here? So okay, so this fills it out. Okay. So we're using the generic BVH builder for both the bottom level and the top level. The only difference is the function that we pass. So in this case, the instance one, and then we will do that. I guess now that the B box is filled in, then we can do something like this. This might be the best place for this. So now this can be both let's see, type, and this is an anonymous mesh. No, we don't have the. Actually, yeah, we do. So actually, no, we can set the no, because we need to actually know the object type. So yeah, we're gonna do it like this. And this is maybe there's a better way to do this. Type. Wait. type mesh. Will that work? Yeah. So now I forget. Start mesh, yeah. So instances i.object, and then this is gonna get casted. Like that. And then array offset is diagonal of bbox. Something like that. Yeah, we're gonna pass this dereference. Right. I think I'm that. And then in the other case, it's just gonna be a sphere. So sphere. Similar type of deal. Actually, I'm gonna copy this whole thing. Right, and then I think this will work. Do we not have a sphere in here? No, we don't. Okay. Where were we? Totally lost my place. Where were we? Diff, thank you. Yeah. So that's on like. Okay. Wait. Yeah. Just completely lost my place. Okay. No, that's not the right one. There we go. A bit of code duplication. We can live with it for now. I think we can find a better way. So yeah, basically compute the instance bounding box and center, and then based on the type. Could we do this in here actually? Let's see. Maybe there's a way. I think we could do this. Yeah. Now that I think, yeah. So, yeah. Like this. Oops. Object page. Offset is that's much better. Let me go and delete this garbage. Yeah, that makes a lot more sense. See, I knew it wasn't the right place, but okay. Get sphere, bbox and center. Array offset is bbox diagonal. Yeah, cool. Nice. That might work. Let me log these. So I can see what kind of the stuff it generates. Because I know the content as well. So no logging. Thank you. Whoa. Alright, offset, and then we're the same deal down here. And while I'm here, I'm gonna name this T-H. Cool. What? Okay, I guess I need to hit return. Escape. Okay. Fair enough. Let's see what that makes. We're gonna do the verbose mode. See what we get. They're probably gonna be way too big. It's not. Yeah. So too big. Did it not say that? Did it not understand my verbose mode? Maybe I had it first. Weird. Huh. Maybe I've broken the args loader? Yak shaving. Args parts might not be working. Verbose mode. Run. I think it should be one of the first. String equals dash v. How do we set the thing? Logger checks for is set v. Okay, so v is set. This okay. Enabled. Oh, not gonna work. Okay. I really changed these to use string equals a while ago. Yeah, there we go. Okay, so yeah, these are way too big. Let's quickly commit this change. Let's see, source utils args. Yeah. Cool. Right, so a friend of mine said that that'd be 0.1. Let's try that. So I think be diagonal. Let's see. It's only used. Yeah, right, for these two. So I think we add change the name of this function, and then actually, yeah, we'll do something like this. Offsets. Yeah, the wall wrapper. I think this will be good. So let's do 1%. So that'll be 10%. Then that'll be 1%, right? And then that'll 0.1%, I think. Blocks. Oops. Cool. I think that. And then this. Let's try that one. Okay, there's something, but still too big. Like way big, and I think I'm setting it incorrectly. And let me actually Oh, these formatting crap. Rerun. That doesn't look like we're offsetting it at place, maybe. Yeah, because these should not be like way out in the distance. These look reasonable, large, but okay, we can work with that. So, ignoring the glitchy print here. We've been live for 25 minutes. Okay, so I think this with the offset it. So, so at this point, we have transformed. Oh, yeah. So we offset the before we transform it. We might want to do it the other way around, I think. Yeah, that's off the top of my head. So we are why are we doing this twice? We're doing it for both? What? That's weird. Was this like this before? Uh, Sphere. It definitely wasn't. Oh, yeah, we did add this. Okay, okay. I guess I just derped it. Okay. Let's try that. The spheres even look right. Okay, that's a bit better. Oh, I actually like that. Let's do it for the meshes as well. So offset, move this like that. Let's see what we get. Okay, that's something. It's a little bit too large. Let's just play offset. And maybe make that into like a define value instead of magic number. Okay, maybe that's good. Let's make this multiply. We're gonna pull in include. Let's see, includes. Did that not work? Yeah. Okay, let's see what it does for different values. So remember, this is the bad one. Then that's what we have. And there's no like correct thing here. Let's get rid of the one because that's obviously bad. And then maybe. Oops. Yeah. Maybe. If this is maybe good, let's try these two. See, they're identical. Like, barely tell difference. Like, no difference. There's like some pixels different. I don't think you're gonna be able to see that on the video. I can see like just barely there are some pixels different. So that's pretty good. Now, the I had before, let's close these, is that a single of this multiply would work for one scene, but it wouldn't work for a scene of different sizes. So I have a different scene. It's an older one that I wrote like years ago that just is huge because I didn't know what I was doing. So let's try and run this. Instead of on JSON, we're gonna run it on scene JSON. See if we're getting banding. Before this scene was giving us a lot of trouble. Looks like it's not giving us trouble. So these offsets are pretty big. And you can see, well, actually, I forgot. Forgot to this mesh, and maybe I can do something like this. Mesh name, and then yeah, spheres are just gonna be anonymous. Yeah. Right. Okay. The room is gonna be the new scene, and the offset is 0.25 because the room is literally like let's see, new scene. I think I wrote this. Well, Blender. I think I've experienced through Blender, but I originally wrote this by hand. It's been edited since, but yeah, it's like thousands of meters in size, basically. That way that happens. I think it's looking pretty good. Let me see. I'm not gonna do too much. There's basically you would if it was wrong, basically. Let me do a couple more samples. But that seems to be working pretty well. It's cool. I think I'm happy with this. Yeah, offset per object offsets. If I find any bugs, I'm gonna fix those. But for now, at least a quick glance, I'm pretty happy. And I want to go to the sauna. So that's it for this video. Let's commit this real quick. I'll let this render background so you can see. Let's see, new terminal. Do we want anything? The logging. Is it like git commit? No, I forget. Was it P? Yeah. So stage this hunk. I'm still getting used to this tool. Yes. Then we gotta split this. How to do it? Learning about this. See, I want to split this, and I thought there was like a command for that. I guess E. Manual hunk edit mode. See bottom for quick guide. Okay. So we're just not gonna do that. Actually, you know, we're gonna stage that as well. Doesn't hurt. Print that stuff. Yes. Yes. Okay. Yeah. Yes. 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 Cool. Okay. Implement per object array sets. Global. Set for the entire CI. It worked. But it seems to work better. And it goes. I think I'm happy with that. Yeah. So that's it. That's it. If you want the whole thing, thank you very much. Yeah. Goodbye. Bye.